Assalamualaikum warahmatullahi wabarakatuh and a very good morning to Dr. Roslawati. My name is Nurin Zazmina binti Azman. My registration number is 06DKA24F1092. Today I will present to you about topic 6, which is momentum. So the first subtopic that I've choose is water jet impact application in engineering. So introduction to water jet impact application in engineering. Water jet impact is widely used in engineering for cutting, cleaning, and material processing. When a high-speed jet of water strikes a surface, it transfers momentum and generates significant force following Newton's second law. This principle is applied in various industries for precise, efficient, and environmentally friendly operation, such as surface preparation, abrasive cutting, and population. Water jet technology continues to evolve, offering versatile and sustainable solutions to modern engineering challenges. So let's move to engineering principle involved. The impact force of a water jet comes from Newton's second law, which is rate of change of momentum. The equation is F equal to rho QV, where rho is density of water, Q is volumetric flow rate, while V is jet velocity. Water jet impact application in engineering. We have first concept of momentum in fluid jets. When a jet of fluid like water exits a nozzle, it carries momentum, which is the product of mass, flow rate, and velocity. The equation is momentum flow rate equal to mv equal to rho qv, where rho is fluid density, q is volumetric flow rate, a is the jet cross-sectional area, while v is jet velocity. Next, we have jet cleaners and water jet system. Principle from this point is high velocity water jet strikes a surface and the momentum transfers from the water to the dirt or coating causes shear and normal forces that remove unwanted material. Momentum effect is first we have the impact pressure or stagnation pressure is roughly proportional to 1/2 rho v squared. Next, we have the higher the jet velocity, the greater the momentum and thus the cleaning force. Next, we have hydraulic system and actuators. Principle is hydraulic system use momentum exchange and pressure forces to perform mechanical work, moving pistons, lifting loads, and rotating turbines. Momentum effect is the momentum of flowing fluid exerts a thrust force when its velocity changes in magnitude or direction. In devices like hydraulic turbines, nozzles, and vents, momentum analysis predict the resulting reaction forces. For example, as we can see in the slide, first we have Pelton wheel turbine. A water jet strikes bucket, changing direction by nearly 180 degrees. The momentum change produces an impulse force that drives the wheel, and force equal to m times v in minus v out. Next, we have fountains and decorative jets. Principle in fountains, water is ejected vertically or at an angle. The upward momentum of the water jet counteracts gravity until it is dissipated by drag, causing the water to rise to a certain height. Momentum effect, the maximum height reached by the jet, neglecting gases, is derived from energy conservation. The equation, as we can see, H equal to V squared over 2T. So let's see particles values. First, we have jet cleaners, high pressure water jets. As we can see in the table of the slide, we have parameter, typical value, and units. The parameter is pressure. Typical value is 100 to 400 in units MPa. Next, we have nozzle diameter. The typical value is 0.2 until 1 in units millimeter. Flow rate in typical value 0.5 until 3 in L over min. Next, we have jet velocity. In typical value is 400 until 900 in meter over second. And lastly, we have density of water. We have typical of value is 1000 in units kilogram over meter cube. Let's move to the next subtopic, which is force exerted on inclined plate. So the force on an inclined plate in fluid mechanics depend on whether it is a stationary plate in a moving fluid or a moving plate in a fluid jet. For a stationary plate, the force is calculated from the change in momentum of the fluid jet with the normal force being. As we can see, the formula is Fn equal to rho AV 2 sine 2 theta. So let's see the example calculation. Its given diameter is 50 millimeter. We need to change to meters, so it will be 0.05 meter. Velocity is 10 meters over second, and density is 1000 kilogram over meter cube. Area, we need to use a formula A equal to pi radius square over 4. So put the data on the formula, it will be pi times to 0.05 square over 4. So we will get 0.001963 meter square. So let's input the area into the formula. F equal to 1000, which is density, times to 0.001963. It is because the area that we get, times to 10, because of velocity, square sine 30, because we got the theta. And we will get F equal to 98.15 Newton. The next example calculation, given diameter, it is 48 millimeter, and we will change to meter, it will be 0.48 meter. Velocity, we have 12 meter per hour second, and density, we have 1000 kilogram over meter cube. So area, use the same formula, and we will get pi times to 0.48 square over 4, and we will get 0.1810 meter square. And input the data to the formula, we will get F equal to 1000 times to 0.1810 times to 12 square sine 60. And we will get F equal to 225.72 Newton. Next, we have the next subtopic in topic 6, which is force exerted on curved plate. The force on a curved plate is determined using the impulse momentum principle, which states that force equals the rate of change of momentum. The equation, as we can see, F equal to rho AV square times to 1 minus cos theta. For this subtopic, let's see the example calculation. A water jet strikes a smooth curved plate and it's turned by 60 degrees from its original direction. The jet has density of water, which is rho, 1000 kilogram over meter cube. Jet area, which is A, 2 times 10 power of negative 4 meter square. Jet velocity, we have 8 meter per over second. Deflection angle, which is theta, we have 60 degrees. So step 1, compute OAV square, which is 1000 times to 2 times 10 power of negative 4 and 8 square. So we will get 12.8. Step 2, substitute into the formula. So F equal to 12.8 times to 1 minus cos 60, and we will get 6.4 Newton. Last but not least, we have last example calculation for this subtopic. Given diameter is 40 millimeter, and we will change to meter, and it will be 0.04 meter. Velocity, we have 15 meter over second, and density, we have 1000 kilogram over meter cube. And area, we will use pi times to 0.04 square over 4, and we will get 0.001256 meter square. And contribute them into a formula. So it will be F equal to 1000 times to 0.001256 times to 15 square and times to 1 minus cos 120. And we will get F equal to 424 Newton. Now we continue to the Q&A session. So I have a question from Luna Jiha. So Luna Jiha, what is your question that I can help you to answer?
So the question is, what a formula we use in force exerted on inclined plate?
So to answer your question, here is your answer. For your question is the formula that we use in force exerted on inclined plates is Fn equal to rho a v square sine to theta. So Najiha, did I answer your question properly?
Yes, Noreen, thank you.
All right, thank you for joining me to the Q&A session. So that's all from me for topic 6 presentation. So thank you.